Hi everyone, my name is Han, and I'm going to do the question 2 of homework 2. So let's begin. Okay. So for the subproblem A, it tells us to find the probability of x2 equals 1. And it is pretty simple because we can just use a total probability theorem. We can say that for every xk equals to 0 and every xk equals to 1, it actually is a partition of the total space. So we can just use p x2 equals 1, it equals to p x2 equals 1, and the condition p x1 equals to 0 times p x1 equals to 0, and plus p x2 equals 1, and the condition x1 equals to 1 times p x1 equals to 1. And we can just substitute the number into it. We have pxk plus 1 equals to 0, and under the condition xk equals to 0, it's 0.4, and we have px1 equals to 0, the probability of it is 0.2, and we have pxk plus 1 equals to 1, and the condition pxk equals to 1 is 0.7, and we have px1 equals to 1, the probability of it is 0.8, so it equals to this, and we have the final result as 0.64. So that's the subproblem A. And for the subproblem B, we use the result of the subproblem A. So we got the px2 equals to 1, the result of it is 0.64, and the px2 equals 0 is actually equals to 1 minus px2 equals 1. So we have it as 0.36. Yeah. And it tells to find px3 equals to 1. I actually use the same method as subproblem A because we have already got the px2 equals 1, px2 equals 0, so we still use like total probability theorem. So it equals to p, there is no 2, why have it? It equals to px3 equals to 1, the condition px2 equals 0 times px2 equals 0 plus px3 equals 1, and the condition px2 equals 1 times px2 equals 1. And we substitute the actual number into it, and we kept the final result as 0.592. Okay. So for the subproblem C, it tells to find px1 equals 0 and the condition px3 equals to 1. We simply use the definition of it, so we can write it as px1 equals to 0 and x3 equals 1, divided by px3 equals 1, and we rewrite the px1 equals 0, x3 equals 1 as px3 equals 1, and the condition x1 equals 0 times px1 equals 0 is also the definition of the condition probability. So now we have, based on subproblem B's result, we actually have the probability of x3 equals 1 is 0.592. And of course, we have the probability of x1 equals 0. So basically, we just need to solve the px3 equals 1 and the condition px1 equals 0. So by solving it, we write it equals to px3 equals 1 under the condition x2 equals 0, x1 equals 0, times px2 equals 0 and the condition x1 equals 0, plus px3 equals 1 and the condition x2 equals 1 and x1 equals 0, times px2 equals 1 and the condition x1 equals 0. It's also a total probability theorem actually, but actually we don't know how to solve the condition probability like px3 equals 1 and the condition px2 equals 0 and x1 equals 0. But actually, it's a Markov chain, I think, but we haven't learned the definition of it. But we know that actually x3 is only relevant to x2 status. It's not relevant to x1 status. So, which means actually only x2 determines the x3's result. So actually px3 equals 1 and the condition x2 equals 0 and x1 equals 0, it's just equals to px3 equals 1 and the condition x2 equals 0. We can just remove the x1. So, and by the method, we have px3 equals 1 and the condition x2 equals 1 is the same result with px3 equals 1 and the condition x2 equals 1 and x1 equals 0. So we write the px3 equals 1 condition x1 equals 0 to this equation, and we substitute the action number into it, and we have the result as 0.52. So now we have all these three elements of the final result, so we can substitute the number into it and get a final result that px3 equals 1 and the condition x1 equals 0, and it approximately equals to 0.176. And for the final subproblem, it tells to find the limit when of pxn equals 0 when n is finite. Actually, I think we need to use the property of Markov chain, but we haven't learned it. But we can think about it like because we have to find it when n is infinite, the result of pxn equals 0. So it's definitely the probability of it will converge to a specific number, and after that condition, after it goes through every noisy channel, it won't change. That's how we can derive the limit of it. So we can set the probability of pxn equals to 0 as a, and of course we will have the pxn equals to 1 as 1 minus a. And after the noisy channel transition, so it actually times transition matrix is 0.6, 0.4, 0.3, and 0.7. But after the noisy channel, it times the transition matrix, it still equals to a and 1 minus a. So we can simply derive an equation from it, and we can get a result like a equals to 3 and divided by 7. So that's the result we want to get. It equals to the limit of pxn equals to 0 when n goes to infinite. So that's all for the question 2. Thank you.